Okay, we are told this given function is one-to-one, and we want to find the inverse. Now, if you weren't told that this is one-to-one, you would need to graph it first and test. And you can see I've graphed it here. We can clearly see this is one-to-one. It passes the horizontal line test because we have a vertical asymptote here, so they're never going to cross. So that would be your first step. But in this case, they've already told you. So all you have to do is start the process. Now, how do you find the inverse? It's actually pretty simple. All you're going to do is you're going to switch the places of x and y. So anytime you see an x, you make it a y, and vice versa. No, that's a 2. Make a difference in the end. And now what we do is we simply solve for y. So I have 3. Okay, so we have 3. Oh, got it to restart. Now I need it to, so 3xy on this side equals 1 minus 2y. Now I want my y's together, so I have 3xy plus 2y equals 1. Bring a y forward, 3x plus 2. And then I divide both sides by 3x plus 2. So then y equals 1 over 3x plus 2, and this is our inverse. So I have here 1 over 3x plus 2, and I better check that. I can, of course, now remember what I wrote down. 3x plus 2. 3x plus 2. So you can see this is a fairly simple process. First, you check for it to be one-to-one. In this case, they've told us, but if they hadn't, you would check to make sure it was one-to-one, and then you know it can have an inverse. Then once you know it has an inverse, all you do is switch the x and the y. Now, obviously, solving for y can often be your hardest part. This was a pretty simple setup, but sometimes it can involve some pretty heavy algebra, so that might be the most difficult part, is just that rearranging to get that y alone, so you're back to a y function. And that is part of that finding the inverse.